Hi everyone. Today we're going to talk about partitioning fractions. And the word partitioning is a very large word that just means to cut or to divide. Partitioning fractions also just means to make fractions. Let's review what a fraction is. A fraction is a part of a whole number. It's also a way to split up a number into equal parts. It is written as the number of equal parts being counted, called the numerator, and the numerator is over the number of parts as the whole, which is called the denominator. These numbers are separated by a line or by the fraction bar. So if you remember, the numerator is over the denominator. To review, the numerator is the part of the whole, and the denominator is the whole. So in our last video, when we had our introduction to fractions, I taught you a little trick. November comes before December, so that will help you remember that the numerator is above or on top of the denominator. November comes before December. So let's go back to that word partition. What does partition mean? Again, it means to divide or to cut. So look at me, I'm going to chop something in half here. I'm going to chop that whole number, or I'm going to divide, cut it, or if you want to use that fancy word, I'm going to partition the whole number. I'm going to divide or cut the whole number, or my fraction in this case. So I'm going to show you a few shapes here. We have a circle, we have a diamond, a triangle, a rhombus, a trapezoid, and a rectangle. So these shapes are all gray. They are all whole. Any shape or item or object is always whole, right? I have a pizza. It is a whole pizza. I have an orange. It's a whole orange until you bite it, eat it, divide it, chop it, right? Or cut it. If I'm going to eat a pizza, I'm most likely not going to eat the entire pizza myself. I am going to cut it or divide it, in this case, maybe partition it, okay, amongst my family or my friends, maybe at a birthday party, right? Now, if I am going to share my pizza with Mr. Spooty and Mr. Pompilio, maybe at my birthday party, I'm going to want to partition my pizza or divide or cut my pizza into 3 equal sections, right? I shouldn't have a bigger section than Mr. Spooty or Mr. Pompilio. That wouldn't be quite fair. We want 3 equal sections, and that's what we've been talking about with fractions here. That also goes along with division, right? We want 3 equal groups, and now with fractions, we want 3 equal parts. So if I'm going to look at my circle here, I could put a bar through the middle here and make it 2 pieces or halves, but now I want to put it and make it thirds. I would want 3 equal pieces. So we're going to start talking in our math classes on how to partition or divide and cut our shapes or our whole items, and how to cut and make them in equal parts. Okay, and in a circle, you're always going to want to start in the center. Or if you come down here to this object, a lot of us like to call it a diamond, I could start in the center. I might want to start at the points. Okay, now how about this guy here? Could I make them in halves? Could I make it in thirds or fourths or fifths? I always like to tell kids, now that we're partitioning, when we get into talking about the words and how we speak about them. Okay, we know halves, 1/2 over that bar. It's not 1/2, it's 1/2. But then you could talk about when you're winning a race, I want first place or second place. But then once we start getting into the other words, you want third place, fourth place, fifth place, sixth place, seventh place. That makes it a little easier to say those fraction words. Okay, so try to think about it that way. Let me scoot down to this next slide here. And I want you to take a look here about where I place these colored lines. Take a look at that circle. Think about that pizza that I wanted to split, right? And now I want you to think about Miss Borden. I split my pizza just between myself and Miss Borden. So I cut the pizza in halves, right? Not 1/2. That sounds a little silly. I split it in half, right? I split it in half. Are my halves equal? Did I split it correctly? Did I split it equally between myself and Miss Borden? If I split it equally, I should be able to fold it on my red line, and we would have the same size and same shape pieces. I think that looks about equal. Now, if I took this red line and I moved it over there, now are my pieces equal? They don't look quite equal, do they? We need to aim for the middle to make something equal. So I need to move back, and now they're about equal again, right? How about over here where my green line is? Did I split that triangle equally? So if Mr. Spooty and Mr. Pompilio, let's pretend this is a triangle piece of chocolate. Are they splitting this piece of chocolate equally? This is Mr. Spooty's piece, and this is Mr. Pompilio's piece. Do you think that's fair? I don't think that's very fair. So that would not be equal. Talk with your class about how I could have split this triangle better to make two equal pieces or two fair shares of chocolate. I'm going to take my green line away. And if you said that I should have started at the point and drew my line this way, you are correct. Because if I folded it on the line, I would have two fair shares or two of the same size and same shape pieces. Now they would have the same size pieces of chocolate, and it would be fair. How about this guy here, my rhombus? If I fold on that red line, are they the same size pieces? I have a small triangle on this side and a small triangle on that side. So I think I chose wisely with that red line being where it is. How about here? The trapezoid. I made two orange lines, so I wanted to make four pieces. Did I choose wisely? Are there four pieces that are the same size and same shape? Did I partition them correctly to make fourths? That means this size or this piece and this piece and this piece and this piece are all the same size and same shape. That means this would be 1/4, 1/4, 1/4, and 1/4. So if Miss Borden, myself, Mr. P, and Mr. Spooty all sat down at the table, we would have the same size meal. I don't think so. Do you think there is a way to split this shape here in fourths? Or maybe there's only a way to split this shape in halves to get the same size and same shape. If I only can split this shape, in halves, do you think I only split this shape in halves this way? So if I folded it on this line, that means this shape and this shape are the same size? Or do you think I take this bar away and go right in the middle? Remember, that's how we do halves. And I fold on that line. That means this side and this side I would fold on, and they would be the same size. If you said I would fold down the middle this way, you are correct, because do you see the top here and the top here are the same size, and the top down here and the top down here, or the bottom down here and the bottom down here are the same size? So if I folded right on this line like a piece of paper, they would match here and here. Because do you notice if I do this and I fold on this line, does my top match my bottom? It's much smaller here and it's much larger down here. They would not match. So I'm going to get rid of that bar and poof, it's gone, and we'll leave that line. How about down here? And let's get rid of this one too. He's extra. How about the pink lines down here? I tried to make 6 equal pieces down here to make sixths, right? Like sixth place. Did I make 6 equal squares in this rectangle? Are they all the same size and same shape, like 6 little ice cubes? Did I do that? Sixths. I made sixths. I think I did a good job there. Now watch what I can do here. Can I take one out and move this in the middle? And what did I make? I made fourths. And I can move this guy out, and I made halves. How about that? And what if I did this? And I drew a line this way. I made 1, 2, 3. I made thirds now. How about that? So there's many different ways to cut some of these whole shapes, aren't there? Some you can only cut one way, or maybe two. Some you can cut multiple ways. Some you can only cut one way. One last shape down here. How about this guy? I cut him with 2 lines, and I made 1, 2, 3. I made fourths. But again, can I remove one line? And I made halves, didn't I? But what if I removed this line and only kept this line? Did I make halves 2 different ways? I did. So we're going to work on showing you on how to partition shapes different ways and making halves, thirds, fourths, fifths, and so on. I have my fraction tiles here one more time that I showed you in the first video that I made for you in our introduction to fractions. So we're talking about partitioning shapes up here. And here are our fractions. So we talked about halves. Remember, that's not 1/2, it's halves because you have 2 pieces. You have thirds, fourths, fifths, sixths, eighths, tenths, and twelfths. And remember, we do skip over a few numbers. You see the sevenths are missing, the ninths are missing, and the 11ths, because we don't use those often. So we know they're not in there, and that's because we don't use them quite often, okay? So the reason why the 3 is down here for thirds is because, do you see, this long piece is cut into 3 pieces. They are in thirds. One thing I want you to notice now that we're looking at the fraction tiles, do you see the halves are here because there are 2 pieces? 1, 2. These 2 pieces make up the same length as the whole bar at the top. But the number 2 is a small number, isn't it? But if I scoot all the way down to the bottom, number 12 is a large number, isn't it? But look how small the number 12 is. So the number 12 tile, or the little fraction tile, is much smaller than the number 2 tile. So when we're talking about fractions, it's much different than when we talk about numbers in general. We normally think a big number is something that is big, right? But in fractions, it's quite the opposite. A smaller number on the bottom actually means the piece is larger. And the bigger number on the bottom means the piece is smaller. So let's think about, do you remember that pizza party we were talking about earlier when I had my pizza at my birthday party? So at first, I only had myself and Mr. Spooty and Mr. P, right? We were sharing a pizza. So there were 3 of us, do you remember? So let's think about these purple pieces. So myself and Mr. Spooty and Mr. P. Look how big our pieces are, those purple pieces, right? Now, let's pretend it's me, Mr. Spooty, Mr. P. And then we invite the 4th grade teachers. So that now is Mrs. Watt, Mrs. Hartman, and Mrs. Miller. So that's how many people now? That's 6 people. So our pieces used to be the purple pieces. Look at now the size. They're the green pieces. So my piece of pizza used to be the purple size. Now it's the green size. So we used to think that a big number meant a big piece, right? But look, my piece got smaller. So the less people we have at our party, the bigger the piece. The more people I have at my party, the smaller the piece. So let's add more people to my party. So it's me, Mr. Spooty, Mr. P, Mrs. Hartman, Mrs. Miller, Mrs. Watt. Now let's add the 5th grade teachers. We have Mrs. Guerreri and Mrs. Hawk. So that's 8 people now. Look, so I used to have a purple piece, then I had a green piece. I added 2 more of my friends because, a party, you have to have your friends. Now look at the size of my piece. The more people, the smaller the piece. So I went from a big purple piece all the way down there. So I want you to be looking at this. The bigger the number, the smaller the piece. The smaller the number, the bigger the piece. It's opposite of the rest of the math that we typically do, okay? I have one last thing I want to show you. It's a short little video.
Welcome to math. Let's learn about equal parts. Shapes can be divided into equal parts. The math word is partitions. Here are 2 circles. Which one has 2 partitions? The circle on the right has 2 parts, but they are not equal. 2 equal parts are called halves. What about a square? Vertical line? Yes. How about a horizontal line? Yes. Diagonal line? Yes. All 3 have 2 equal partitions, halves. How about 4 equal partitions? Cutting a square in half and in half again makes fourths. Sometimes we use the word quarters. Some shapes can be divided more than one way. Ready for a question? How can we show 3 equal partitions on a square? Yes, thirds. Is there another way? Got it. What about a circle? Those pieces aren't equal. Find the center. Now the 3 sections are equal. Let's look at some other shapes. Rhombus, rectangle, star, hexagon, and oval. Let's add some partitions. Which shapes show two equal partitions? The rhombus and oval show halves. Which shape shows four equal parts? The rectangle has fourths. How many parts does the hexagon have? Three partitions. What about the star? It is divided into two unequal sections. Well done. See you next time.